Hi there and welcome to this example video. In it I want to show you how you would determine to what number set a certain number belongs to. It is basically going to be a sequence of questions that you're going to ask yourself to choose or eliminate which number groups or number sets that a certain number can belong to. So let's get started. Now basically the order in which you're going to ask the questions is you're going to ask, is it real or not real? Okay, the next you're going to ask is it, if it's not real, it's just not real, and that's where you'll stop. If it's real, then obviously the question would go, is it rational or irrational? Because your real numbers can be divided into rational or irrational. Okay, if it's irrational, then it's only real and irrational. If it is rational, then it could be that it's an integer. Change color again. It could be an integer. Now, if it's an integer or it is not an integer, if it's not an integer, then it's just real, rational. If it is an integer, it's real, rational, and an integer. Now, if it's an integer, it could be positive or negative. Okay, so is it positive or negative? If it's negative, then it's a real, rational integer. That's it. If it's positive, then it could be either, well, it's definitely, if it's positive, it is definitely a natural number, and it's definitely a counting number. The only exception would be is if it is 0. The number 0 is neither positive nor negative. It is 0. So I suppose, is it positive or negative? If it's not positive or negative and it's just 0, that's the only number that will not be a counting number. All other positive numbers will be counting numbers. 0 would be a counting number and a rational number. Now, just so this might be difficult for you to remember what order the questions go in, and it basically just comes back to that Venn diagram that we draw. Here's the real numbers, and I'll use the symbols here. The moment I choose inside a circle, I continue my questioning. The moment I'm outside of the circle, I stop my questioning, and that's where I stop. So a real number is divided into two parts. So there's the rational numbers, Q. I should have sticked with the same color, shouldn't I? Okay, and there's the irrational numbers. Let's try that. The rational numbers, and there's the irrational numbers. Okay, now the moment I am, if I go inside the rational circle, then I'll continue my questioning. If I stop at the outside, then it's just real and rational. We'll do some examples and you'll see what I mean. Okay, then once it is that, we ask the question, and they can just make this pink. Okay, that was the question, is it rational or irrational? And then if it's rational, we ask the question, is it an integer? Okay, is it an integer? The moment that I go inside the integer circle, I continue my questioning. If I don't, then it's only real and rational. Okay, so I'm inside the integer circle, for example, and then I ask, is it positive or negative? Okay, so the integers are divided into two parts. Let's do it like this rather. It's divided into positives and negatives, and the positive numbers, all the positive numbers are the counting numbers. So those are the ones, the natural numbers. Okay, sorry, yeah, the natural numbers. Then here, if it's positive, if it's not positive and it is not negative and it is a counting number, if it includes 0, that's the only one that falls, that does not include, let me rather say that, that's the only one that does not include the counting numbers. Okay, so he is not a counting number, and that would be 0. 0 would be in 0 only. All the others would be in 0 as well. As so I suppose I should have better drawn this inside circle as, there we go, and then there we go. You see the counting, or the natural numbers, are just slightly bigger than the counting numbers. And why doesn't want it? Because it only includes 0 as well. So 0 is the one number that does not fall into the natural numbers, positive number that does not fall into the natural numbers, counting numbers I mean. Okay, so let's quickly go and look at a few examples on how we would actually do this. The number 5, is the number 5, so we go from the outside in, is the number 5 a real number? Yes, it's a real number. And non-real number would be the negative square root of something, so it is a real number. If it's real, is it rational, irrational? Now, the only numbers that are irrational that we're going to look at is numbers like pi and the roots that does not simplify into perfect roots. So, for example, the square root of 16 is a perfect square, okay, but the square root of 2 is not. So 5 is a rational number. So is it rational? Yes, it's rational. Okay, I'm continuing. I'm inside that circle already. So now I must ask the next one. Is it an integer? Yes, it is indeed an integer. So an integer means it's a whole number. Yes, it's an integer. Now, is it positive or negative? It is positive. The moment it's not 0, it's both natural numbers and counting numbers. Okay, and there we go. If it was a 0, then it's only a natural number. It's not a counting number. Okay, because we don't count 0. So 0 is the only one of the integers, positive integers, that's not a counting number. Okay, so let's look at the next question. The square root of 10, is it a real number? Yes, it's a real number. The only non-real are negative square roots. So it is a real number. So I'm inside this first circle. Once I'm inside there, I ask the question, is it rational or irrational? This is an irrational number. We can't think up what's the square root of 10. You'll have to use your calculator. When you do that, you'll see it has this decimal continuation that has no pattern that you can visibly distinguish. So this square root of 10 would be an irrational number. And the moment I don't go inside the next circle, I can stop. It's just there. It's a real irrational number. And I can go on to the next question. Okay. This number, is it a real number? Well, it's not the square root of a negative, so yes, it's a real number. Is it a rational number? Okay, well, again, a rational would be, if it's written as a decimal, it would be if there's no distinguishable pattern. Here we can clearly see a distinguishable pattern, 3, 3, 3, 3, 3. It's recurring. Now, rational means I can write it as a fraction. Now, there is a way of writing this number as a fraction. Just for example, multiplying, this is 9.3. Don't do that. 9, 3, 3, 3, 3, recurring over 1. If I multiply the top and the bottom with 3, notice that 9, 3, 3, 3, 3 recurring. If I multiply that with a 3, what do I get? 9 is 28 over 3. 28 over 3. That would be an example of how you would write this as a fraction. But that would just mean it's not irrational. Now, if it's not irrational, it's rational, so it's rational. If once I ask, is it rational, the next question is it an integer? Well, this is not an integer. Integer is a whole number. This is a fractional part, and so that's where I will stop. This is a real rational number, and that's where I stop. Okay, next number. Oh, this one is already a fraction. The moment it's a fraction, not unless it simplifies. So let's say this was 8 over 4. Yes, that's a fraction, but it simplifies to 2. So that would have been a fraction, but it's actually an integer. But this is not. 8 divided by 7 has a decimal part or a fractional part. So this is a real number. And is it, so that's the first question, is it a real number? Yes. Next question, is it a rational number? Yes. Where's rationals? There we go. A rational number. If it's a rational number, the next question, is it an integer? No, it's not an integer. The moment I say no is the moment I stop my questioning and I go on to the next one. Oh, great. Here we have the negative square root. That's the easiest one because I know it's simply irrational. Okay. All of the other numbers, number sets form part of the real number sets. So if it's irrational, it's none of them anyways. Okay, last question. There we go. We've got a fraction again. Again, this fraction does not simplify, so it's only a real rational number. Okay, again, how do I know that? I asked, is it real? Yes. Is it rational? Yes. Is it an integer? No. Okay, so just remember this: real, rational, integer, and is it positive or negative? Okay, I suppose just ask the question, is it positive? If it's positive, it's a natural number. Oh, I think the first thing you should ask yourself is it 0? Is it 0? If it's 0, then it is only a natural. It's a rational, a real or rational integer counting number. Okay, no, natural number. Okay, the moment that it's positive, it's a real, rational, integer, counting number, and natural number. So if you can remember RQZO plus, then you should be fine. Thank you very much for watching. I hope this helped you solve this much quicker, and we'll see you in the next video.